So your voice is too low.
Probably there is some internet problem. A sequence is a, you just first apply, you just first write a sequence is a function, or sometimes it may be considered as mapping from natural number n to real numbers. Now here 1, 2, 3 up to any natural number. If you write, suppose the elements of the sequence are 1 by n, then what will be the sequence? 1 by 1, that is 1, 1 by 2, 1 by 3, 1 by 4, in this way. Okay, where 1 by n, this will be fn, that can be as xn, and for any natural number where n is an element of a natural number. Okay, now is it clear to all of you? Now fn may be
Yes, sir.
1 by n,
Yes,
1 by
sir.
n square, whatever it may be. Now you
Yes,
just
sir.
now okay, now you just write that a sequence is convergent. A sequence is convergent if there exists a uh, finite real number L, finite real number L, small l, as its limit. So you can easily write that limit n tends to infinity. Here, suppose xn, this xn will be equals to L. Means it can be written as, have you gone through function of several variables? All of you? Epsilon delta, that concept, have you got or not?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then you just write that absolute value, this xn, the difference between the limit L and xn, if it is taken less than epsilon, then for all n greater than equals to n0. If it is exists for all n greater than equals to n0, the absolute difference between the limiting value and the function, if it is kept less than epsilon, then if you just consider, suppose this is point the L on this line, so you can consider right hand side, it will be L plus epsilon, L minus epsilon. Now you just consider the function value f of n, basically which is xn, lies here. Then obviously this x value must be, this value of n will be greater than n0. If n greater than n0, then if you put this n as an argument, which is a natural number, which produces the functional value xn, which lies between, suppose here, then obviously this difference is taken epsilon. For any n greater than n0, this exists, this relation exists, then you can consider that this particular sequence is convergent. Sequence is represented by xn.
Sir, what is N0?
N0 is some fixed value. After that, if you go more than n0, suppose n0 is some fixed value, then n0 plus 1, 2, 3, 4 up to infinity if you go, always xn, the absolute difference between the xn and L will be less than some small number, that is epsilon. Okay, so that you have considered that this point is L, then you have allowed absolute difference between L minus epsilon, L plus epsilon. Now you have kept the function value f of n, which is represented by xn, within this range. Then obviously the value of n greater than equals to n0. n0 is some fixed value on this line, so that n0 plus 1, n0 plus 2, n0 plus 3, any value if you take up to infinity, always this will be true. Means this f of n tends to this limit L. Okay, is it clear?
Sir, is epsilon also a constant value?
Yes, yes. Epsilon is a small constant. Okay. Okay. Now you just write that you have to go through some examples, then it will be clear to you.
Sir, please move the slide, sir. Sir, convergent slide. Can you show? Yes, sir.
Sequence is convergent if there exists a finite real number L as its limit.
Sir, voice is too low, sir.
Yes, sir.
This finite real number is L. Okay. And absolute difference between xn minus L, it will be if it is kept less than epsilon, then obviously for n greater than equals to n0, I am showing some examples, then it will be clear to you. Otherwise, it will not be clear. Okay. I am showing some examples. Now write the example here. If limit n tends to infinity, 2n plus 1 by n plus 1, if it is equals to 2. Then you see, what is this portion? This portion is f of n. Sometimes it is written as xn. And this portion is 2 is L. So if you just write that the absolute difference between 2n plus 1 by n plus 1 minus L, L is 2. If it is less than epsilon, you don't know what is the value, but you just consider some small value. Now if you consider that, if you just solve it, then it will be 2n plus 1 minus 2 into n minus 2, 2n minus 2 by n plus 1. Basically, when you take the absolute, then it will be 2n minus 2n, it will be cancelled. So 1 by n plus 1, it is less than epsilon. So you can consider that n plus 1 greater than 1 by epsilon. Can it be written?
Yes,
So,
sir.
Yes, sir.
so or
Yes, sir.
n greater than 1 by epsilon minus 1. So if this is n greater than this value, which value is greater than this? So n0 must be taken some value 1 by epsilon minus 1 plus 1, because some greater value you have to take, greater natural number you have to take. So if you take this as a number, and if you go in right side, plus 1 up to infinity, always this exists. So you can consider that this tends to this finite limit. The sequence is, this sequence is convergent.
Sir, why plus one?
Yes.
Sir, why you consider this
Yes.
and
Why?
not
Good question. Why plus 1? Because it is n greater than that. You have taken a greater value. You have taken a greater value, plus 1. So you can consider
So,
N0 is
sir,
the
N0 value must be 1 by epsilon naught minus 1. We have,
Value of
so why we
can
have
write
read
plus 1 plus 2 anything.
basically you have, when you have studied for function of several variables, for every epsilon there is a delta. For every epsilon there is a delta. There is some relation. So here for every epsilon this will exist. If you take the N0, if you take plus 1, some greater value, it is n greater than that, you have taken it is plus 1. Some greater value you have taken and you go to in the right side. Always it will be applicable. Okay. Yes.
so,
Tell
but
me.
N0 here is not an integer.
Hmm?
N0 will be an integer or a real
Yes,
number.
yes. An integer. Natural number. Otherwise, how can you natural number to real number mapping? Na?
So the question is to prove the convergent or not.
Yes. Means
Okay.
you have to prove that for some N0, if you go right hand side, always this will be convergent. That you have to prove. So you just see, write the relation, then it will be clear.
If their limit exists, then it must be the convergent.
In your experience, that there some circular neighborhood you have taken, so that you go to the if suppose the point is 0 0 in two-dimensional space. In your previous experience, I am just one minute. In your previous experience, this will be, suppose this point is 0 0. Suppose the function will be whether it is continuous or not, or limit exists or not. There are two procedures. Then you have taken, suppose f of xy minus L less than epsilon. Now here you can take a circular neighborhood. So what you have done, x minus 0 plus y minus 0 whole square less than delta square. So for every epsilon there is a delta. That relation you have established. Here also you have established that some value of epsilon, for some value of epsilon, if you take n0, that 1 by epsilon minus 1 plus 1, if you take some value which is greater than that, and n0 plus 1, n0 plus 1, if you go in right hand side, for every where the relation exists. Okay. Now is it clear to all of you?
So, sir,
Sir,
in this question, value of N0
square
is 1 by
this.
epsilon.
Hmm?
Or N1 value.
Yes, delta. This already you have gone through, na? You have told. Okay.
Sir, x minus 0 whole square.
सर एक से स्क्वायर होगा
Oh, sorry.
Square, sir.
I have.
You missed that square.
Okay. So if you take any point here, then for that it will be exist. So you have just established a relation, nothing else. You are establishing a relation that for every epsilon there must be some n0. There must be some n0. Previously for every epsilon there is a delta. Okay. If you keep the function value and that within the specified limit, then there for that reason there will be a delta. That relation you have established. Here is also that same thing, just in a different approach. Okay. Now is it clear to all of you?
Sir, it is
for convergence of the limit n should be greater than n0, so n0 should be 1 by epsilon minus 1, so plus
But
1.
greater than, it is given greater than. So you have taken a greater value. 1 by epsilon minus 1 plus 1. On that you just proceed right hand side. Okay. Some greater value you have taken. It is greater than, not greater than equals to. Okay. Then you have just taken the value. Okay. Next.
So from the definition, it is given that if there exists a finite real number as limit, then we can define as convergence, right, sir?
Sir, why is there no delta in that?
So why can't we define
Here
by
you
the
just taken
fixed
some,
value, sir?
here the definition you just go for any value in the right hand side of n0, n greater than n0, where n is the natural number, which is greater than n0, that is also a natural number. If you go right hand side, then obviously, if you keep the function value within the absolute difference between where the function value and the absolute difference between function value and L, if it is kept in less than epsilon, obviously n greater than n0. N0 also a natural number. Okay.
Just
Next
please
is
give an example of non-convergent.
non-convergent. Okay.
So
Just
that
I am
it
showing.
will be easy for us to understand the difference.
Sir, in non-convergent limit will not exist, sir.
Limit will not exist. Limit n tends to infinity.
It must tend to infinity.
It will not go
Give
to
an
infinity.
example, sir.
1 by n. For 1 by n, if you go n tends to infinity, it will not a finite value. Okay.
Then we can say that if limit does not exist, then it is non-convergent.
Divergent. Yes. Then infinite series. Next topic is infinite series. Mainly this will be the main topic for you. Infinite series. Infinite.
Series 1 by n is a divergent function, means divergent series.
No. 1 by n is divergent series. Yes, that I shall show. 1 by n is divergent series. Why divergent?
By
Can you?
Convergent because limit will exist.
Yes, 1 by
Sir, n
n.
tends to infinity.
Yeah, n
1 by n is a divergent series. Why?
1 by n
You
tends
write
to 0.
Limit exists, sir.
1 by n. Yes. 1 by n.
It
No,
exists.
that cannot be taken as an example. I am showing you. N.
Yeah, n होगा.
N. Yes.
Sir, n will be divergent.
Yes. N. Now 1 by n is a divergent series.
Yes, sir. 1 by 2, 1 by 3.
1 by 3. Why? Can you tell?
Divergent.
Why?
Sir, 1 by n is a convergent series, na?
No. 1 by n.
Is there a value of
Why?
5 square by 6?
Suppose I am showing you 1 by n. Just 1 minute. If you write 1 by 1, 1 by 2, 1 by 3,
The infinite
1 by 4, 1 by 5, in this way, suppose you just proceed. Now, here you see that 1 plus 1 by 2. Now 1 by 3 plus 1 by 4. You just consider these two. Okay. Here, this denominator is higher.
4.
1 by 4. So the value of 1 by 3 plus 1 by 4 is greater than 2 into 1 by 4. Is it true or not?
Yes, sir.
Yes,
Because
sir.
the summation of these two. Then similarly, 1 by 5, 1 by 6, 1 by 7, 1 by 8. Here this is the highest
4
denominator.
into 1 by 8.
So 4 into 1 by 8. This will be greater. So if this series
Sir, we
is
can write a general
divergent,
term, sir. N plus 1 by 2.
if this series is divergent, then obviously this will be divergent because this is higher.
yes, sir.
Okay. So that this will be considered. Okay. So 1 by n is a divergent series. I am showing you.
Sir, but one thing, sir, in the convergent and divergent series, sir, you have only considered a particular term of the expansion, not the summation. So, sir, then how can it be?
Yes. Here, basically what you have done just the previous example that a few minutes ago, you have made a group. You have made a group. Half, then 2 into 1 by 4 plus 4 into 1 by 8 plus 8 into 1 by 16 in this way, so that it will be 1 by 2 plus 1 by 2 plus 1 by 2 in this way. So it will be n by 2. So you can easily write that 1 plus n by 2 as limit n tends to infinity. It does not converge. Is it clear to all of you?
Yes, sir.
Sir,
Yes,
if
as
we
infinity
go by
comes.
basic method, then sir, epsilon naught on L, sir.
No. I am telling about the series, the summation. I am telling about the summation. Summation will be 1 by 2 because you have made group, na? Group of 2. Suppose 1 by 2 plus 1 by 3 plus 1 by 4. Now 1 by 3, 1 by 4 you have taken as a group. Here 1 by 4, 4 denominator is highest. Okay. So obviously this very particular summation is greater than 2 into 1 by 4 because here 1 denominator is less, so its value is higher. So 2 into 1 by 4. Similarly, suppose 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8. Obviously this summation will be here this denominator is highest. So
sir, how many terms we have to consider in a group?
Yes, you can consider, na? Because this is every term is 1 by n. So you can consider that group of 2, 4, 8, 16 in this way. Okay.
Yes, but the thing is that no only like you have in the definition you have given only for a particular term that
No.
whether
Here, in case of series,
but you are
summation.
considering summation here, sir.
In case of series, this is summation, na? I am
Sir,
considering
what
about
do we
series.
mean by convergence?
Convergent of a
Means
series.
the
Why
summation
we
will
cannot take 1
be a
by 2 plus
finite
1 by
value,
3?
or each term has a finite value.
No. You have to take in such a way so that you have to prove, na? You have to compare it with some other series. You have to compare it with some other series.
Other series.
Other lower series. If that lower series is divergent, it must be divergent using comparison test. Okay. Here you see that if you here this denominator is highest for this 1 by 8. So obviously 1 by 5 is greater than 1 by 8, 1 by 6 is greater than 1 by 8, 1 by 7 is greater than 1 by 8. So obviously this summation is greater than 4 into 1 by 8. Similarly, next 8 terms, it will be 8 into 1 by 16. So it is coming half plus half plus half plus half in this way. So it will be, when n tends to infinity, it will be n by 2. So 1 plus n by 2, n tends to infinity. So this series does not converge. Okay. Is it clear?
One question: what do you mean by
Why
convergence?
one can't?
Means
It is not
summation will
answered.
tend
Can't we
towards
use a
finite
One is, you have just omitted the first. You have
What
omitted
is the
the first.
difference between convergent and divergent?
Yes, that I am saying that if you just have to write the definition.
Sir,
Sir, why you are adding plus one faster?
sir, it is difficult to understand 1 by 3 plus 1 by 4 is equal to 2 by 4.
Put the value.
Is not equals to.
Put the value of
Comparing with
x
some.
belongs to natural
You
number.
are comparing
Greater
it
than
with
2
some.
by 4, na sir?
If 1 by
Greater
3
than
plus
2 by
1 by
4.
4 is greater than 2 into 1 by 4.
No.
Yes, sir.
1 by
Okay, it's
3
greater than.
greater
Here,
than 1 by 4.
no.
So it is.
This is also a,
Sir is just taking approximation, I guess.
yes. You have taken some approximation that you are considering some lower series, some lower value series, which is a divergent. Obviously, this will be divergent. Okay.
Divergent.
Achha, next you just write let an.
So it is an example or infinite series.
This is an example of divergent series. Okay. Let an be a sequence. An be a sequence of real numbers. Then the symbolic expression a1 plus a2 up to an, which is represented as capital sigma n equals to 1 to infinity an, that will be, or simply you can represent same an that represents this will be n equals to 1 to infinity, that will called infinite series. That is called infinite series. Infinite series. Have you written? Now if we take n equals to, or if you take r equals to 1 to n, some fixed integer, if you take ar, then it is known as partial sum. This is not that. If this n is infinity, then it will be infinite series. Otherwise, this is known as partial sum. Okay, all of you have written?
Yes, sir.
Then
Yes,
you just write three things. One,
If there are will not equal to infinity, then it is partial sum.
Sir, please show the previous slide again, sir.
The previous slide.
Okay, sir.
Okay,
Done.
thank
Done,
you,
sir.
sir.
Done, sir.
then you just write series. Here types of series you just write. A series convergent.
Sir, your sound is very slow, sir. You're not getting your voice.
Okay, a series is convergent or divergent and oscillating. Now oscillating also oscillates finitely, infinitely, that we will discuss. A series is convergent means it tends to a finite limit. Okay. Divergent not tends to a finite limit. You just write. And oscillating, oscillating finitely.
For infinite value, it is oscillated between two finite values.
Now, can you now some examples?
Once explain oscillating series.
Can you again show the table?
Sir, can you explain again this things like
Using examples, these two things we will discuss.
Sir, you increase your volume, sir.
Basically, another
Sir, I think your mic is above your head, so.
Okay. Now is it clear?
Little
Yes,
bit,
sir.
yes.
Yes, sir. Now it is clear.
yes.
Okay. Now, you just write the definitions. Already you have written the definitions. You just go through the examples. Capital sigma r equals to 1 to infinity. 1 by r into r plus 1. What will be the series? This is an example of convergent series. Okay, you just write 1 by 1 into 2 plus 1 by 2 into 3 plus
कीर्ति माइक म्यूट कर ले
Sir, Karun, mic on.
कर ले
1 by 4 into 5. In this way it will go. So this can be written as 1 by 1 minus 1 by 2
Please mute your mic.
plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus, in this way can it be written? So you can easily write minus
Yes,
1
sir.
by 2, 1 by 3, 1 by 3, 1 by 4. This will go on. So it will be 1 minus 1 by n plus
1.
1. Now if n tends to infinity, 0, so it tends to a finite limit. So you can easily consider that this series is a convergent series. Okay. Now next example. Divergent series. Capital sigma n will be divergent. Capital sigma n. So it will be 1 plus 2 plus 3. So it will be in this way. N by 2.
The sound is a bit low.
N plus 1.
Sir, sound is very slow.
Probably some other teacher is also taking class just beside me. Probably this is a problem. Okay. Now, is it clear to all of you? As n tends to infinity, this is divergent.
Yes, sir.
Then what is oscillating? Give an example. Suppose capital sigma minus 1 to the power r plus 1, where r equals to 1 to infinity.
Yes.
This is also
Yes, it is oscillating between -1 to 1. -1
1
and 1.
minus 1 plus 1 minus 1 plus 1 minus 1. So for even number of terms, it is 0.
Oscillating between -1 to +1.
Oscillating between two finite limits. Okay. So these are the examples. 0 and 1. Okay. Now we will discuss about two important series. One of them is known as P series. First we will go through where the terms are taken. Capital sigma 1 by n to the power p. So you can easily consider that 1 by n to the power p means 1 by 1 to the power p plus 1 by 2 to the power p plus 1 by 3 to the power p. In this way it will go on. So
this is called P series.
P series where p is greater than 1, this is a convergent series. If p is less
P
than
is
1,
in power.
p is power 1 to the power p, 2 to the power p, 3 to the power p, 4 to the power p. In this way, if p is greater than 1, it is convergent. Just apply. Just few minutes ago I have discussed 1 plus. Now you just make group.
Sir, in equal to 1, it will be also divergent. Sir. That less than equals to.
We will discuss it. We will discuss every possibilities. Okay. So it will be 1 plus, you just write 1 by 2 to the power p plus 1 by 3 to the power p. Just make a group. 1 by 4 to the power p plus 1 by 5 to the power p plus 1 by 6 to the power p, 1 by 7 to the power p. Make a group. Now if you make this group, this denominator, if p is greater than 1, then this will be this p 1 by 2 to the power p is lesser than
1 by 3 to the power p.
1 by 3 to the power p. So you can easily write, and p for every possibility, just write. You can write 1 plus 2 by 2 to the power p if you take the denominator is less. So if you just compare these two terms, then these 4 terms, you just consider these 4 terms.
It must be
So
2
if p greater than 1, then 3 to the power p will be greater.
4 by 4 to the power p, 4 by if p greater than 1, then 4 to the power p is less than 7 to the power p.
So sir, here must be 7 ki power p.
Yes,
Yes, sir. 7 की power p and 3 की power
Sir,
p.
how you are writing that, sir?
7 power p.
Yes, I am comparing.
power
This
p.
cannot be written. This cannot be written. You can only compare these two. You can compare these two. You can't write it. Okay. You can compare these two.
Sir, greater than
If
sign,
p
then it
greater
is
than
greater or less.
p greater than 1.
Then in the previous
P greater
example, you
than
say
1.
that we
Our
have to
voice
take the lower series, but here we take the higher series.
Yes, sir.
Yes.
Yes, sir. How?
In case of, suppose, I am just showing you. Suppose there are some terms in a series. If you take some higher series, this is higher than this, 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 and you can prove that this higher series is convergent, then this series must be convergent. convergent. Okay. Similarly, one series is given to you. If you take some lower series, this is lower than this. This is lower than this. If this series is divergent, obviously this will be. Is it clear to all of you?
So, sir, for convergent, we have to take
Sir,
higher
divergent
series.
P less than equal to 1, sir.
Sir, for convergent, can't we take lesser
No.
series?
Here you just see one thing. Just I am showing you. Here you just see. If you write 2 to the power p, 2 by 2 to the power p, 4 by 4 to the power p. Here you just write that if p is greater than 1, 4 to the power p is less than this.
Yes, sir.
If p is greater than 1, 4 to the power p is less than 7 to the power p.
Yes, sir.
Then 1 by 4 to the power p is greater than 1 by
7 to the power p.
7 to the power p. 1 by 5 to the power p is less
greater.
than this. So you can easily consider that 4 by 4 to the power p, this will be greater than this if p greater than 1. Is it true or not?
Yes.
You have compared with 1 by
Yes,
5 to the
sir.
power p, 1 by 6 to the power p, 1 by 7 to the power p.
True, sir.
So you have just added this 4 by 4 to the power p. So 1 by 4 to the power p, 1 by 4 to the power p, 1 by 4 to the power p, 1 by 4 to the power p. Okay, you have compared that 1 by 4 to the power p, as 4 to the power p is lesser, so 1 by 4 to the power is higher than these terms if p greater than 1. Have you understood?
Sir, greater than
Sir,
sign
sir,
used to.
can you please explain why you are taking the two numbers as one group and next one 4 numbers as one group?
One group, yes.
For comparison.
Because you
Now we
want to
should
transfer
read
this
up-
particular series into a geometric series using comparison. Using
Okay,
comparison, you have to transfer it into a geometric series so that it will be 1 plus 2 by 2 to the power p. So 1 by 2 to the power p minus 1
-1.
plus this will be 2 square. This will be 2 to the power 2p. So 1 by 2 to the power
Minus
2
2.
into
2p minus 2.
2p minus
minus
2p
1.
minus
Yes,
2.
sir.
So r will be
1
this.
by 2 to the power p minus
So
1.
there are formulas that you know 1 minus r to the power n
Yes.
by 1 minus
R.
r for p greater than 1.
Yes, sir.
For p greater than 1, 1 minus r to the power n by 1 minus r. So it will be written as 1 by 1 minus 1 by 2 to the power p minus 1 for. Now is it clear to all of you? Because this r
Now
to the
the
power n
summation
is
becomes convergent, then we can say that the
if p
original
greater than
series is
1, then it will
convergent.
be yes. If p greater than 1, then you can consider that this is convergent. Okay.
But sir, how do we get to know that whether
That
to take a lower series or higher series?
equal
Yes.
sign.
Suppose this is common sense that the summation will go to a suppose finite limit. If some higher series go to finite limit, then the lower value if is in comparison, that also goes to finite limit. Similarly, in case of divergent, if some lower series is divergent, then obviously that series also divergent. Okay.
Sir,
Just simple.
can't we prove
Sir, P less than
convergence by
equal to 1,
taking
sir.
lower
How do we
series?
decide that we have to consider a lower series or higher series for this sequence, particular sequence? That means we will conclude that this series is convergent after writing the sum of infinite GP and all that. But before that, we have considered higher series here. First time, 1 plus 2 upon 2 to the power p.
Because you have to go to that particular formula na, of geometric
We have
series,
to make a GP series.
GP series. So that on the
Even
basis of the value
even
of
if we take lower series, won't it create an infinite GP?
GP series for
yes,
easy
Sir,
you have
is
to
it
go
calculation.
to the GP
confined to
series.
take? Sir,
For
is
easy
it confined
calculation.
to take
For easy
only lower
calculation.
series for
Mainly this is the
convergent?
easy calculation. Suppose one I am showing you. Just go through an example. Then suppose the Cauchy's root test is included in your syllabus. Just from another concept, I am just showing you.
But is it specified to take lower series for convergence?
Ma'am, order get the.
Tell me. Suppose I'm showing. Just apply your previous concept here. Suppose limit n tends to infinity.
Convergent series is not enough.
Limit n tends to infinity. Suppose nth root of a of n. What is a of n? A of n is the element of the series, nth element of the series. Okay. Now, if this L is less than 1, then it is convergent. If L is greater than 1, it diverges. Okay. Now, how it can be proved? Suppose L equals to limit n tends to infinity an to the power 1 by n. If this is less than 1, then you can consider that this is convergent. Okay. Now here suppose L minus epsilon, this will be less than n power 1 by n. You just write less than L plus epsilon. What you are telling? This is the absolute, this represents the absolute difference, because L plus epsilon, L minus epsilon. L is the particular value. Now if you consider that this is R, okay, this is R, you have to go to the geometric series. You have to go to the geometric series. So you can consider this value is R. Then if you write, compare that an less than R to the power n. Okay. And capital sigma R to the power n, where R equals to 1 to infinity. If R is less than 1, this is convergent. Is it correct or not? This is the allowed range. This is the 1 minute. L is the middle. This is the allowed range. L minus epsilon, L plus epsilon. We are telling this L basically an power 1 by n. Okay. Then you just consider that this, you have to compare it. You have to compare with some geometric series. Okay. Now, if this will be considered, if this will
अरे
be
नवनीत म्यूट कर ले भाई.
If this will be considered as R, so that this very particular n is less than n power 1 by n is less than this. Okay. So n if it is less than R to the power n, then you can easily compare with some geometric series. That R1 plus R to the power 1 plus R to the power 2 plus R to the power 3. If R is less than 1, this is convergent. So if you can implement this concept that n power 1 by n equals to ranges between L minus epsilon to L plus epsilon as the absolute value range, then L plus epsilon is considered as R. If you consider, then n obviously less than R to the power n. So R to the power n is basically a geometric series. 1 plus R square plus R cube.
So here R to the power n is convergent, so we can say to the power n to the power 1 by n is also convergent.
Yes. Now is it clear to all of you?
Sir, in the previous one, we take comparison. So why we should use equal sign?
Both where equal sign we have used?
In the previous one, P series, in P series.
No, greater than.
Oh. Sir, when we take higher series, it will not be equal sign. He is saying that.
But that will be 1 plus half. 1 plus half.
Sir, a series will be divergent when the limit tends to infinity.
Greater than 2 by 2 to the power p. So why should you use equal?
That just I am seeing. This we have understood. This is clear to all of you?
Yes, sir.
Please repeat the last part.
Okay.
Sir, can't we take the lower value and can prove that it is convergent to L minus epsilon?
For convergent, you have to take higher. For divergence, you have to take lower.
Sir,
is divergent, that is divergent.
Sir, is it specified to take higher value?
Yes,
less than
otherwise, if higher will be go to if some higher value series will be convergent, obviously lower will be convergent. Okay. If lower value series is divergent, obviously this will be okay, sir.
Sir.
Now, any question for p greater than 1? Here you have seen p greater than 1. So the common ratio will be less than 1. You go to geometric series, na? Some known point you have to go, na? That 1 by 1 minus r to the power 1 minus r to the power n by 1 minus r. So it will be convergent. Okay. Now is it clear to all of you? You have to make group.
Yes, sir.
You have to make group 2, 4, 8 in this way. You have to make the group. Okay.
Actually, we have to make a GP series.
So capital sigma 1 by n is divergent.
Sir, the second equal to in this slide, it should be, sir, less than. So why, sir, it is equal to?
Less than equal to 1, sir. Divergent.
For equals to, just check.
Sir, actually, he is saying about the third line. It will be not that equal to, it will be less than.
P greater than 1.
1 plus 2 by
1 plus 2 by 2 to the power p, that will be.
Oh, 1 plus 2 to the power p, this.
Greater than 2 by 2.
The next
Below
line.
that line, sir.
Oh,
No,
at
sir,
the starting,
the assignment sign, sir,
at the
the
starting you
equal to
take
sign.
We can't use equality sign now.
Oh.
Yes, sir,
less than, that's what the.
Okay.
Yes, sir, that one.
Okay. So this is nothing but the comparison. Okay. Now to up to this.
Yes, sir.
Is it clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Sir,
Yes, sir.
sir, next day, please give an example of this thing, P series.
Okay.
Sir, please upload any assignment in the MS Team.
Okay. I shall upload today. If p is less than 1, it is divergent. Divergent.
Okay, sir.
Sir, please upload the
Thank you, sir.
note.
Thank you, sir.
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 Thank you, sir. Thank you, sir. So can we leave, sir?
Okay.
Thank you, sir. Have a nice day, sir.
Thank you, sir.
Thank